Hello everyone, and thank you for participating in today's webinar. On behalf of BIS Research, Blighter Surveillance Systems, Raytheon and DroneShield, I would like to welcome you all to our emerging tech webinar on Counter-UAS Technology, protecting critical assets from drone intrusions. This is Rahul Papne, Principal Analyst for the Aerospace and Defense Practice at BIS Research. I will be the moderator for today's event. Today, we are hosting four of the finest scientific minds in the counter-drone industry who have been instrumental in easing access to products and knowledge for the consumers. Firstly, we have our host speaker, Sudhir Unyal, lead analyst for the Aerospace and Defense Practice at BIS Research. He holds profound experience in strategizing and enabling actionable insights for the stakeholders of the aerospace and defense industry. We also have Geoff Moore, who is the head of critical infrastructure at Blighter Surveillance Systems. He is a thought leader and regular contributor to conferences and industry publications on counter-drone technologies and infrastructure risk management, with real-world experience of solutions delivery throughout the UK, Europe, the Middle East, and Africa. We also have Evan Hunt, who is the High Energy Laser Campaign Business Development Director at Raytheon Space and Airborne Systems. In this role, Evan leverages his extensive knowledge of laser subsystems, joint combat operations, and military logistics to provide leadership and strategic guidance to directed energy capture efforts and high-energy laser product line developments. Evan is also the lead for counter-UAS strategy across the corporation. We also have Matt McCrann, who is a Vice President Sales at DroneShield. He is an experienced business development executive, having previously built and led business units for enterprises, delivering innovative technology to military, intelligence, public safety, and law enforcement communities worldwide. I thank all the panelists for their gracious presence. A very warm welcome to all of you. In this 60-minute of session, Geoff Moore will provide a brief on understanding counter-UAS solutions and the sectors that are likely to adopt the most. Further, he will also be emphasizing on the factors that needs to be taken in account for selecting counter-drone for military applications. Even Hunt will help us in understanding the prominent military use cases and the key emerging technologies in the counter-UAS industry. Further, Evan will also highlight the challenges associated with the deployment of counter-UAS systems and how will the military conflicts look in the future. Matt McCrann will provide his insights on the counter-UAS technologies adopted across critical infrastructure, commercial venues, airports, and other applications. He will also be discussing upon the mission planning process to conduct counter-UAS operations. In the next 60 minutes, we are all keen to learn from your experience in this industry, and towards the end of the discussion, I will open the panel to the audience for any questions. I will request everyone in the audience to kindly mute your phones during the session and type in the questions towards the end of the webinar. Any questions that we are not able to answer today shall be reverted offline. Having said that, let me open this panel for discussion and invite thoughts from Sudhir. Over to you, Sudhir.
Thank you, Rahul. Let's begin with understanding the risks associated with unmanned aircraft systems. There are basically two types of risks that UAV pose. One is physical and other is non-physical. So physical risk is all about drones dropping harmful or explosive payload or damaging via collision. In today's world, drones can also be used for conducting physical attacks. Apart from threat to the world leaders, drones can also be used to plan disruption on civilian infrastructure as well. Since 2014, there has been around 8,000 plus close calls with an aircraft reported to FAA. Authorities across the globe struggle to deter curious hobbyists who fly over critical infrastructure, professional sporting venues, and other large gatherings, for the fear of crash that might damage assets and injure people by use of explosive, biohazards, or other harmful agents. Even the most secure organizations and facilities are vulnerable to penetration from the sky. Drones interfering with an aircraft and breaching secure perimeters, UAVs have proven that their associated physical risk can affect not only the individuals and organizations that operate them, but the people, structures, and organizations in their vicinity as well. Now, when we talk about non-physical risk, it's all about capturing sensitive data via a variety of sensors threatening for privacy, intellectual property, or operational security. Risk management professionals must consider how to protect their organization from unwanted data collection by outsider UAV, as these platforms and sensors become increasingly sophisticated and attainable. From capturing sensitive documents, meetings, and research and development activities to tracking movement of key personnel and material, drones represent yet another threat vector to mitigate. Data collected from legitimate UAV operations present legal and regulatory risk as well. Privacy advocates and watchdog groups are concerned by the collection, use, and protection of data collected by UAVs. Now, thus to mitigate these different kind of risks involved with the use of UAS, let's hear from Geoff what are the counter drone solutions and which sectors are likely to adopt it the most. Over to you, Geoff.
Okay, thanks, Sudhir. So as we move into this topic, first of all, let's define some of the terminology because there's a lot of confusing terminology. So before we look at counter-UAS, let's just define what a UAS is. So UAS stands for unmanned aerial or aviation systems, and that really accounts for all of the different types of aircraft that are out there, both unmanned autonomous as well as remotely piloted, from nano drones the size of your hand up to full-scale military drones, and all of the different control solutions that can go with them, from very light touch mobile phone-based systems all the way through the professional controllers up to the military systems, which are effectively remote cockpits. These systems, the sort of systems that we're seeing today in use around the world, really divide into a number of categories, from the hobby users through to commercial users who are using drones for a variety of things, from inspection through to remote aerial photography and a variety of other uses, through to the military users, obviously, of course. We click there, please, Sahir. Move on a slide there, please. There we go. That's it. So yeah, so we've got a variety of different users. Today, we're primarily looking at the uses in hobbyists, commercial users, and the military. And whilst these are beginning to be quite widespread, they're mostly isolated individual systems with very little overlap of flight patterns and the like. In the future, as more services like delivery services and urban air mobility, remote taxis, and that kind of thing start to come into popular use, we're going to see far more complexity, overlapping air patterns, and a much denser sky with a lot more activity. So if we now move on to what that means in this environment, we've always got within the use cases of these various different modes today and in the future, we'll always have the opportunity for either careless or criminal or clueless operators who are using drones in the airspace to cause disruption and to carry out unlawful activity. So if we move into what the counter-UAS space looks like. Next slide, please. There we go. So in the counter-UAS space, really, we're going through a series of different stages really within counter-UAS, starting out from the deterrent factor, where we're using regulation and licensing restrictions to stop users or reduce the risk of users using UAS in restricted spaces. We can then use a range of different sensor technologies to detect and track both the drones themselves and the operators. And then once we've identified these threats and identified them as true threats, we can then use a series of other technologies in order to be able to either disrupt the operation, disrupt the pilot, or disrupt the drone itself, or in extreme cases, be able to kinetically or electronically destroy the drone itself. The areas on the left-hand side of the screen there are really where the commercial counter-UAS space is in the deterrent and the detect and track and identify space. At the moment, in most jurisdictions, it remains illegal to interfere with aircraft in flight of any kind, including drones. And so really the items on the right-hand side currently sit within the realm of the military or government-controlled counter-drone. And so primarily we're focused on the left-hand side for commercial. And it's likely that this is going to stay the same for quite some time until we get to a point where issues around liability and around the control of counter-drone technologies has been fully defined in law, and we're not quite there yet. So moving on, so in the choice about where these technologies are going to be used, actually the question is a really simple one to answer. At the moment, if there aren't any UAS present in a particular area, then we don't really need a counter-UAS system. And if there are UAS and they don't pose a threat to the type of infrastructure that's in place, and again, we don't need a UAS. But this is based on the fact that at the moment, we don't really have a huge density although there are a lot of drones being used, they're not massively densely, the sky is not massively densely populated with drones. And at the moment, we don't really need counter-UAS systems everywhere. But as we see this technology proliferate, we're going to find that more and more places have more and more drones. And everywhere where there are more drones, there's a bigger and bigger risk of us having to have of things going wrong and rogue or non-cooperative drones in the airspace. And that's when we start to see the requirement for counter-UAS in more locations. So final slide in this piece. So the
Thank you, Geoff, for providing your thoughts on counter-drone solutions and the sectors that are likely to adopt the most. So currently, as we see, the airspace security is becoming increasingly important. It is very crucial for the end users to understand anti-drone systems is aligned to their need or not. Now let's hear from Matt on what different factors you need to consider while evaluating a counter-drone system for airports, critical infrastructure, and other applications. Over to you, Matt.
Okay, thank you, Sudhir. So this builds on what Geoff just outlined previously with the different actions that can be taken in the full cycle of counter-UAS. So as mentioned previously, the disrupt and destroy capability is really in the realm of military and government entities right now. So from a commercial perspective, we're looking more at the detect, identify, and track aspects of that chain. So understanding the regulations is a key consideration when identifying the right counter-UAS system for specific markets. So prisons, airports, public venues, utilities, oil and gas, what is within the realm of their jurisdiction to actually enact. So the enabling technologies that will be deployed need to align with the regulations and the authority that they have to operate them. The environmental aspects and the overall coverage area will also define in those different markets the equipment that is best suited for the solution. And then in different markets, there's also budget constraints. So when we see things like corrections or prisons, they're usually dealing with a much different budget constraint than a commercial airport. So all these are key considerations in the deployment of counter-UAS throughout different markets. Next slide, please.
Thank you, Matt, for helping us understand different factors to evaluate counter-drone for airports and different application areas. Now, let's hear from Geoff what different factors that need to be taken into account when selecting counter-UAV technologies for military applications. Over to you, Geoff.
Thanks, Sahir. Okay, well, just like with buying anything for the military, the process is never simple and it's often long-winded. And there are a bunch of criteria that some of which are directly to do with the performance of the equipment, but a lot of which are not really anything to do with the performance of the equipment and are more to do with local conditions. If we look at the performance-based criteria, anything that we're doing in the counter-drone space, we always know that it's going to be part of a layered solution depending on what the specific use case is. And within counter-UAS, when we could be dealing with, in a military application, we could be dealing with anything from a large-scale fixed-wing, long-range UAV, similar to the sort of thing we saw used on the Aramco strike recently, which is effectively more like a cruise missile than a drone, all the way down to something the size of the palm of your hand, a nano drone that's being used for tactical surveillance on the battlefield. The range of technologies that are required to fulfill all of those requirements is incredibly broad, and nobody's going to be able to provide you with any one solution that does all of those things. And so it's really important to be able to understand which classification of drones you're actually able to act against, so that your end user within the military can understand where your components fit into their operational requirement and how they're going to do things. You also need to be able to understand that this thing is going to be deployable by the kind of people who are going to be working with it in the military. We have a huge advantage with the military in that all of the personnel they're there for their entire tour of duty. They're often really well trained and they do what they told and they follow orders, which makes life, in some ways, makes life quite easy, but also we have to fit into the way they work. And so it's important that we have the flexibility and we have the experience to be able to deploy solutions into that environment. At Blighter, we've deployed a lot of military systems into active service in the Middle East and in Southeast Asia and a lot of other places. And we know what the procurement cycle looks like in the different armed forces in different parts of the world. One very, very important factor here is that many of the technologies that we could be seeing as part of a counter-drone solution will be classified as military use or dual use. And as a result of that, we may see export controls when we're moving different components of that technology around from place to place. If you're buying equipment from a NATO country, it might be difficult to supply that equipment into a non-NATO country, for instance. You will always see restrictions on export and import that we now need to be able to take into account. There are also variations in the standards between different countries which need to be taken into account. And you also need to be prepared for the slow procurement processes and the amount of trials that you will need to do to demonstrate that your technology really works. And often those trials will need to be done at your expense. So there's a lot of non-technology considerations around the supply of counter-UAS equipment in much the same way as there are around the supply of any other piece of collateral into the military. And it's important to take all of these things into account. But obviously, right at the moment, people are really, really focused on counter-drone technology. And it's important to make sure that we each understand what the capabilities of our own equipment are and that we can fold that capability into whatever our end user's operational requirement might be. And whether there's an existing C2 platform or whether there's some other piece of equipment that you need to be able to work with, we need to offer the flexibility in the military environment to be able to connect these things together to create a complete picture for the end user.
Thank you, Geoff, for letting us understand the factors to evaluate the counter-UAV technologies for military applications. So as we see, the major and minor militaries around the world see unmanned air vehicles as the future of air power. The proliferation of military drones worldwide is accelerating at an alarming rate, and currently more than 20 countries are having the armed drones, with a dozen more seeking to acquire armed UAVs as well. Drones already make up a large share of vehicles in operation in major militaries, and the percent of air power and flight hours they make up in the air forces is expected to grow significantly. As a result, the market for drones is projected to increase several fold in the coming decade, with the US, Israel, and China playing a key role. The US massive military budget and long history of cutting edge military research guarantees that it will be a major source of military UAV spending. The United States restrictions on military equipment sales allows other countries such as Israel and China to play a big role in the international markets. The growing use of UAV by militaries and rebel groups also means that there should be a corresponding increase in demand for anti-UAV technology. Militaries are the foremost adopters of counter-UAV technologies and have been used by the defense organizations across the world. The growing use of military drones around the world has sparked off a race to develop and procure the most cutting-edge anti-drone systems in the world. The anti-drone systems have been found to use different techniques such as GPS spoofing, laser guns, machine guns, and hybrid systems or the missiles. Now, let's hear from Evan on the prominent military cases and the key emerging technologies in this arena. Over to you, Evan.
Thank you. So I'm on the first slide, which is countering the threat, defending civil infrastructure. The first thing to say is even our military customers and those military use cases often demand defending civil infrastructure. So we have Air National Guard bases that share runways with civilian airports. We have some military missions which involve defending Department of Energy resources such as refineries and oil fields and everything in between. So we have we have other military applications which involve defending key government facilities, and so do many of our export partners. So that means that our first military use case does still involve defending civil infrastructure, and usually that is in highly populated areas, residential communities, and the drone threat flies so low and so slow and is so ubiquitous that we need to find, our military personnel need to find ways to counter that threat, detect, ID, deter, or defeat as they defend these civil assets. So that's why you have this near-term emergence of jamming technologies, which are non-kinetic, and that means if you have to use weapon systems around civilians, especially in only quasi-military applications, maybe you have law enforcement personnel, as some of the previous speakers spoke about. Maybe you have untrained personnel that are now filling an air defense role. You can imagine that our regulatory agencies aren't comfortable yet giving these new anti-drone operators hard kill mechanisms or kinetic kill mechanisms, such as surface-to-air missiles or even machine guns. So in this first case, we're starting to see the emergence of jamming systems, which have proven to disrupt the command and control links on Wi-Fi and GPS and other control frequencies such as GLONASS. At first, they started out being handheld and being used at very, very short range. But for military application, you need to be able to reach out and affect potential threats at least a kilometer away and hopefully more. So we team with a company named BlackSage, which creates towers, which include radars, directional jammers on multiple frequencies, and electro-optic sensors. And those are all-in-one solutions that provide for 360-degree detect, ID, and jamming, which is really a good solution for this defending civil infrastructure use case. The next, and in many ways the more traditional use case on the next slide, defending military infrastructure, involves really defending forward operating bases and military locations that are in much more austere environments and don't carry the same regulatory concerns, don't involve the same level of collateral damage concerns, because usually they're not around residential areas. And this use case comes with a different set of problems. This use case really is all about max range and max capability, and it's because these air defense operators usually are highly trained. They have a number of systems available to them, even traditional systems like the Patriot missile system, for example, to defend larger air threats. Now they're being faced with smaller, potentially swarming threats that pose just as much of a threat to these military bases. And so they want to use technologies that can detect an ID at the farthest possible range. It doesn't have to be necessarily a visual ID, which is different from the civil use case. Because you're in an environment which doesn't have any civilian aircraft around, if you have a radar blip at a long range that is identified as an enemy, you can probably launch a surface-to-air missile effector at that target and not be concerned about collateral damage. So these systems really demand detection at the farthest possible range, ID and a fire control level track on a radar target, and then a missile system which is capable of flying a very, very long range and guaranteeing a hard kill against a drone. So, you know, the issue today is residential or these commercial drones, the smaller drones that are widely available in the market and have been modified to be military systems, are jammable. They are relatively easy to deter at the moment with a directional jamming system, although jammers can't operate at the same range that our sort of kinetic kill missile systems can. But the drones of the future are likely to be very difficult to jam, especially the drones that are built for military application. So that's why we've heard this idea of layered defense prior. That's nothing new to air defense. Air defense missions always involve some sorts of layers, and drone targets are really new air targets, so they just need new technologies to counter them. Raytheon, we've invested quite heavily and worked with the U.S. government on a number of new technologies to deal with this problem. The first is on the third slide. On the left is the high-power microwave system, which we call phaser. It employs a high-power microwave that is fired in a directional manner and has an ability, a unique ability, in a invisible pulse form to really hard defeat the command and control links within a drone and cause it to fall out of the sky. And this has a nice directional beam which allows you to defeat multiple tightly packed drones with one quick burst. It's been widely demoed for the Air Force and the Army, and the U.S. Air Force has contracted Raytheon to send one of these systems overseas for operational field assessments this year. The next system is the high energy laser weapon system. This is, if the high power microwave is your shotgun, the high energy laser is your sniper rifle. You can see it has a very advanced multispectral targeting system at the top of it. That's that sensor bowl. It's a electro-optical and infrared sensor that is really good at IDing small drones at very long range. And it not only IDs, the laser beam, which operates at 1 micron, actually fires out the primary aperture of that sensor. So it's an invisible, instantaneous beam of light that at very long range, you can be tracking a target with your sensor, and then when you want, you press a button. We use a little gaming controller, and you start to burn a hole in it, much like you would use a magnifying glass under the sun to maybe burn a leaf on the ground. It's the same type of effect. So, you know, these two systems serve different purposes. The laser weapon could theoretically eventually be used for defense of civil infrastructure because it's so precise. Laser weapons don't miss. You know exactly what you're hitting at exactly the time you're pressing the button, and it's not hard to train operators to use the system. We have a Xbox 360 style gaming controller that we've trained non-air defenders to use the laser weapon in just a couple hours, and then they've gone out and engaged and defeated a number of drones. So we've shot down over 100 drones so far with the laser weapon. The Air Force has contracted us to build and deliver 3 of these systems overseas this year. The Howler system, which is the 3rd system on this page, is currently employed by the U.S. Army today. It features a very advanced K-band radar, which was originally designed for counter-rocket artillery and mortar and has proven to be incredibly effective against drones at very, very long range. And a launcher on the side of this truck launches Coyote missiles, which are really hybrid drone missiles. You know, they've taken technologies from both that allow you to have very max glide capability and keep your cost relatively low for a missile system. And Raytheon plays very heavily in this business. The Stinger missile over on the right is employed all over the world with the U.S. Army today. That too has been modified specifically for counter drone use and has great effect in the interim mobile short range air defense mission that the U.S. Army has. And that's it.
Thank you, Evan, for briefing on the military use cases and key counter-UAV technologies. Now, as we know, there is no one-fit counter-UAV solution for different industries when it comes to identifying which technology is best to detect or respond to a drone. It is difficult to decide what is right for a particular problem, which is why a scalable and customizable solution is important. Now, let's hear from Matt on which different counter-drone technologies adopted in different application areas such as critical infrastructure, prisons, commercial venues, and others, and how these technologies are classified as per different applications. Over to you, Matt.
Thank you. So we've all touched on the layered approach, and that being the most effective counter-UAS solution that one could deploy, regardless of market. So on the detection side, having those layered capabilities, multi-technology, you essentially leverage the strengths of each method while mitigating any weaknesses or vulnerabilities of any one specific method. So common adoption on the commercial side for detection usually falls under the 4 that I have listed there: radar, radio frequency (RF), optical, so a EO camera, and sometimes even acoustic, depending on the application. Now, going back to the considerations that we made up front, a lot of those considerations will drive which of these layers gets implemented into the field. One being budget or cost. So applications for prisons are less likely to use a radar layer for the fact of it's cost prohibitive with a lot of their budgets. Whereas an airport would definitely want to leverage radar and RF and optical, so they can have full situational awareness for their airlines, flight lines. taking this layered approach further, we go into a little bit what touching on the same that Evan mentioned previously with the countermeasures. A layered approach being a what we call a soft kill, which is jamming. That's frequency jamming, all the way to the more extreme, higher risk threats there with a kinetic solution. So the high-powered lasers, directed energy type solutions, microwaves, which we see definitely more on military side. The path to having that used in the commercial sectors is still a ways away, but that is being explored, as mentioned previously, for certain civilian or critical civilian infrastructure. Next slide. So, and here are basically the markets and some considerations specific to those markets. So, military is obviously quickly identifying the threat and then deploying the appropriate countermeasure. They have full reign and ability to do so. So the options are open more so for them than the civilian or commercial markets. With airports, the key is situational awareness. Which technologies, which enabling technologies or layers provide full situational awareness, and also a recording or tracking mechanism for their analysts or security personnel to actually make use of. With prisons, a main driver is the cost-effective solutions. They have to scale these out to multiple facilities, and they don't have the budget of, say, a defense or even federal level law enforcement does. So they are more likely to deploy lower cost sensors, in most cases RF, some combination of the other layers being optical are also popular. Same thing with utilities and gas. Now their budgets are larger than, say, your state-run prisons. However, they have a unique challenge, and a lot of these facilities are unmanned facilities. So they don't have the personnel on site to respond. So the solutions that are deploying in these markets involve a lot of situational awareness, a lot of remote monitoring, and communication across the different stakeholders, so the proper response can be enacted when a threat is detected. And public venues offers a very dynamic vector for counter-drone, for the fact that we could be talking about stadiums, conference centers, large public gatherings. So the environmentals are very dynamic in this domain, but the real emphasis is on portability, pop-up capability, to be able to adapt to those different environments.
Thank you, Matt, for explaining the counter-UAS technology adoption in different industries. So as much as these technologies are successfully tested in controlled environments, their success and applicability in the real-world scenarios is yet to be completely established. Anti-drone technologies are still in a very nascent stage, and companies are basically trying to build best systems involving multiple technologies to deal with all possible contingencies. However, their effectiveness is yet to be established. Now, let's hear from Evan on the challenges associated with the implementation of counter-UAS and how will they be addressed. Over to you, Mr. Evan.
Thank you. So really, each counter-drone solution needs to be tailored and customized for the specific customer and the specific use case. There really isn't a one-size-fits-all solution for every class of drone and for every customer. We've talked in this forum today about some customers have larger budgets with needs for hard defeat capability at very long range. Other customers have smaller budgets and can't truly can't get beyond the regulatory hurdles necessary to employ weapon systems that might have collateral damage, and therefore they need precise non-kinetic systems. And that's why directed energy and jamming is really being looked at heavily for those types of use cases. Ultimately, though, we do know you're going to need a detection system. You're going to need a way to track these drones as they come in. You almost always want a way to positively ID, and that's with an electro-optical or infrared sensor, so that you can zoom in and see the target and confirm it's not a bird, confirm it's not a friendly drone, maybe confirm that it's carrying some sort of threatening munition. And then you want to give your operators options for defeat, right? And nobody wants just a single type of effector. Ideally, you might try to jam first, and if jamming doesn't work, then you can employ a kinetic kill solution. So the challenge associated with counter drone operations is tightly linked to the threat itself, and the drone threat is rapidly evolving. It is rapidly evolving and probably evolving faster than the counter drone technologies, because it has a huge commercial market behind it. So we need to get over regulatory hurdles. We need to define the requirements associated with counter drone operations for certain customers. Then, as we talked about earlier, we need to line up the budgets to fund development of systems and training to support those requirements, and ultimately test and move these systems to the field. And that will probably involve not standing up a new section of the military that does counter drone operations, or even a new section of the TSA or a new section of law enforcement. It'll probably mean additional training requirements on those different personnel that already perform a base defense or an air defense or a security type of mission. So these systems need to be specifically designed to be learned quickly, just like drones are so easy to teach, right? I have a 12-year-old son. We have a drone. He learned to use it in five minutes. Our counter drone systems need to be that simple if we hope to compete. And we need to assure our customers across the board that we can prosecute the counter drone mission in a safe manner and not make mistakes where we accidentally hurt civilians or civilian infrastructure when we're really trying to protect it. Thank you.
Thank you, Evan, for highlighting the challenges and their addressable solutions. So to conduct any kind of counter-drone activity across any area, it is very important to plan your mission accordingly. Now, let's hear from Matt on the mission planning process to conduct any counter-drone operations across any area. Over to you, Matt.
Thanks, Sudhir. So this is really attacking what happens after the solution is implemented, that we can control, that we can plan for, to make sure that the solution that was selected, deployed, can be as effective as possible against the emerging and evolving threat. So some key areas of mission planning require identifying of the key stakeholders. This is not, Counter-UAS strategy does not involve a single individual, an IT person. It involves a team, whether that team is made up of internal security staff or personnel, or external agents such as law enforcement, federal agencies, or a mix of the two. Those key stakeholders need to be identified up front. And what also needs to be identified is what is the interaction and how is information passed among those stakeholders to limit cognitive burden, and make sure that the right individuals have the information they need to respond appropriately, whatever is within their realm of responsibility for responding. So that not only requires communication channels, but also training for that personnel to understand the moving parts and the responsibilities of the other groups involved. All of that will drive a standard operating procedure for when a detection is made. How do we assess the threat? What are the different levels of threat? And then how do we respond based on the threat level? These are things that need to be defined up front and not left to judgment calls during an operational scenario. The 10-year-old who accidentally flies a drone over a military installation does not require, I would hope, does not require a kinetic solution to intercept and mitigate that threat. Whereas the unknown drone that has a payload capacity and can carry 15, 20 pounds of potentially explosive equipment would require a different response. So in the standard operating procedure, what is key is how do we make that assessment as quickly as possible and get that information to the people who need it, to act quickly and to mitigate the threat. And then also built into that are post activities. So making sure that there's a audit trail or reporting involved. So the operations can routinely be monitored, made more effective, improved upon, and can adapt as well. The threat will adapt. The behavioral patterns will adapt. So how are we monitoring that to make sure that we are in a constant loop, an iteration loop, where the solution and the components involved and even the operational knowledge are improving and keeping up with the UAS threat. And then part of that post-action planning is to audit the process itself. What is the information we're capturing? Is that the effective information needed to perform our job? And then also, do the right people have access to that information, or can we improve upon there? So really just monitoring the process, auditing the process, and making sure it's effective and that it can be sustained over long periods of time. That's the key target with mission planning. Now, with the next slide here, here's an idea of how threats get assessed. There are different threats. I heard one of the other speakers mention clueless, careless, and criminal. And that is a very good way to describe the type of operators, the human behind the threat that we're dealing with. But also other factors that need to go into the threat itself, the drone, is to understand its capability, understand its intent as best as we can, and do that in a timely manner. There are, at the bottom end of that pyramid there are low threats that can cause some severe issues. Maybe it's not a threat to life, but it can have severe economic implications, such as with the incident in Gatwick last year, where flights were grounded for over a day. That's millions and millions of dollars lost and travel disrupted due to a unknown threat with an off-the-shelf drone. So things like that, what is the proper level of response? It all comes back to how are we assessing the threat and how quickly can we make that assessment? Thank you.
Thank you, Matt, for describing the importance of mission planning for conducting counter UAV activities. So as we know, different counter UAV systems rely on two elements, that is detecting and intercepting the drones. Under detecting and tracking systems, different systems such as radar, radio frequency, electro-optical, infrared, acoustic, combined sensors are used, whereas for interdiction, RF jamming, GNSS jamming, spoofing, laser, nets, projectile, and other are used. Now let's hear from Geoff on which are the elements of counter-UAS technology that are likely to require the most investment in the coming years. Over to you, Geoff.
Okay, thanks, Sudhir. I think the first point that's really important is that we're right at the very beginning of this industry. The UAS industry and the commercial space and the widely used space is really at its revolution 1.0. There's a lot of things to happen in the future. In particular, we're seeing in the background the development of unmanned traffic management solutions and remote ID for drones, which are going to facilitate the much more crowded airspace that we're going to see in the future. Once that's in place, that's probably going to be the key driver for the next generation of counter-UAS solutions that can work in that space, where once all of this traffic is in the sky, it's all going to need to communicate. It's all very likely to communicate over the same wireless systems using the same protocols. It'll be impossible to tell the difference between a good drone and a bad drone until the bad drone does something bad. And in that time, a lot of the counter-UAS solutions that we're currently looking at, particularly in the area of things like jamming, simply might not work anymore because we don't want to disrupt a sky full of drones that nearly all of which are doing a good job. So there's quite a lot of things that will change in the near future, but let's just have a look at some of the areas in particular where I believe that we're going to see specific investments. Next slide, please, Sudhir. So if we look at the framework of counter-UAS as presented earlier, in the first instance, we need to see an awful lot of development of regulation. In every country at the moment, in every jurisdiction, we're seeing people hurrying to put in place regulations and certification systems for pilots and for drones to try to control how these are used in the airspace. And it's very slow to evolve because everybody's doing it for the first time. There's no such thing as industry best practice at this point because most of it has never been done before. The next area really is in the detection space. We've already mentioned that there are some specific technologies that are widely used, particularly around radar, radio frequency direction finding, and signal interpretation, signal interception and the like. But the information that comes from these systems is very, very complicated. And at the moment, it takes specialist training generally to be able to interpret the information that you're getting from these systems. So there's quite a lot of development needs to happen in that space. In addition, when we consider the very, very cluttered spaces, places like airports and pieces of civil infrastructure where we've got a lot of ground movement from legitimate traffic, and increasingly in the future, a lot of air movement, it's extremely difficult to get accurate readings of location from moving targets inside of those spaces. And many of the technologies that are currently available simply are not capable. Things like with technologies like radar, for instance, it's really important to understand that radar isn't just one technology. There are a dozen or more different types of radar systems. They work at different wavelengths. They have different encoding systems, different ways of detecting targets. And in many cases, that's very, very difficult to interpret. So we're going to need to see a lot of development in there for how that works. We're also going to have to see some development in things like artificial intelligence and machine learning to interpret that information, to deliver more useful intelligence to operators It's no point in giving an operator in a security environment a complex set of things to look at for drones. He's already dealing with 1,000 other threats and 1,000 other types of activity on the ground. We need to be able to deliver classified threat information to operators in the same way that he would receive that information from other sensors, from other security solutions. So that a lot of work needs to be done there. And really the only way to get there is to invest in much more machine learning to be able to interpret the complex data that comes out of these sensors and give it to the operators in the right kind of format. That requires actual deployments of systems in the field so that we can gather the data that we need, so that we can create machine learning based systems that can properly and accurately interpret information to provide tracking and identification data. On the area of drone defeat, we're still some way off having a solution, any solutions on the market that are 100% predictable in what they will do if we try to use them to destroy all types of drones in the sky, from tiny drones to big drones. There simply isn't anything out there which we can use 100% predictably and safely, particularly in the civil environment, to be able to achieve this. And so there's some considerable work that needs to be done then. And we also need to think that particularly in the civilian environment where we could have threat drones that could be carrying toxins or explosives, we don't necessarily want to bring them down onto the ground where the people are. So we sometimes want to have those threats removed from the environment, not simply destroyed. And so we need to, although there is some good work happening in that space to look at things like capture drones, the removal of drones, there's still an awful lot of work to be done there. And in that space, it's actually drone technology that's holding us back, because the drones that we're using for capture are not as good as the drones that are being used by the attackers. So there's a lot of work that's required there in those different areas. If you just click on there, please, Sadia. And one more time. So integration is the other area where there's a huge amount of investment in development required. And this is not just in one area or not just at one level of integration. In the sensor integration, whilst we do actually have some standards for communication within the industry at the moment, there still are not any really widely adopted interoperable standards for communication between different sensors. We all understand that there's no silver bullet. We all understand that we need to use multiple sensors connected to platforms in order to be able to build the variety of different solutions that we need. But people are very slow in adopting these communication standards that are interoperable with different platforms so that people can plug and play the different sensor technologies that they need. Also, as mentioned previously, the information that's coming across from these sensors needs to be a lot more functional for operators, so that they can interpret the information more accurately with less requirement for training. As I said, unfortunately, in the commercial environment, we are going to continue to rely on the same security infrastructure that we always have with the same kinds of operators. We cannot expect to train these people up to be radar operators and RF engineers. We need to be able to dumb down the information and correctly and automatically classify targets and pass that information on to people using the kind of security management platforms that they're already used to. There's a level of integration also required in between what are currently being developed as in many cases as pretty much standalone counter-drone platforms, and how we actually integrate them with the existing infrastructure and the existing security management and air traffic management systems that are already in place, that many places have already got. This is not only to protect people's return on investment, because they've already made huge investments in these security management solutions, but it's also to create more of a single pane of glass interface for operators who are sitting in control rooms, so that they can use systems that they're familiar with, following the same risk management principles that they do in other parts of their facilities, but now adding in the additional risks from counter-UAS. Finally, there's a dimensional shift required really in the security management world, because in the smart city, safe city world, people are still thinking about this flat two-dimensional space of what a city looks like. We need to start thinking about the third dimension. UTM is probably going to be the driver towards to the second phase, really, of both of drone usage in the urban space, but also driving towards the second generation of counter-UAS. And that's going to require a lot more sophistication. We can't use a sledgehammer to crack a nut in this particular case. we won't be in a position to be able to use particularly RF dangerous solutions in this space where the sky is already crowded. It'll be like looking at a crowded street full of people. You can't tell the good guys from the bad guys, and we'll be in exactly the same place in the sky in a few decades' time, where you can't tell the good drones from the bad drones. And so a lot more focus on this side of intelligent management of the airspace and not simply trying to knock drones out of the sky is going to be part of the way we have to move forward in the counter-UAS space.
Thank you, Geoff, for briefing on the different elements of counter-UAV technologies. We also see here the swarm of drones are likely to change the future of warfare. These are basically low-cost, intelligent, and inspired by the swarm of insects, and these swarm squadrons could revolutionize the future conflicts. Their ability to work together in numbers will certainly benefit any military agency. Now let's hear more from Evan on how he sees the future of military conflicts and how counter-drone technology needs to be evolved. Over to you, Evan.
Thank you. So, as we've talked about, the number of drones is expected to triple, if not quadruple, by 2023, since their inception in 2004. And certainly, militaries are all catching on to the fact that this is an incredible tool to be used for surveillance and for precision strike. And that means that we can absolutely expect swarming, autonomous, unjammable drones to be used in large effect in coming conflicts, not just by formal militaries, but by asymmetric actors such as terrorist organizations. That means drones will get faster, they will be harder to defeat, they will act more independently and have longer range. Advances in battery technology, lithium-ion battery technology, are complementing this evolution, and that means that drones will have larger flyout range, be able to carry bigger weight loads, bigger weaponized payloads, and in many cases get smaller, even harder to see, harder to defeat, able to sneak in to certain places that traditionally would have been considered very, very hard to get into. So we have a big challenge on our hands. The U.S. Department of Defense is certainly taking that challenge seriously. You all probably saw the news. They're standing up a new counter-drone lead at the Pentagon, and they're rapidly working on counter-drone requirements. But I think, just like the evolution of electro-optical sensors, just like the evolution of precision-guided munitions, drones as weapons are here to stay, and that means we need to get smart and efficient about dealing with them very, very quickly. And they're a very varied threat. So they are more, the Department of Defense classifies them from group 1 to 5. And that really means it's anywhere from a DJI Phantom 4, a very, very small drone that travels about 60 miles an hour and flies pretty low, has pretty short range, all the way up to an unmanned flying aircraft. So your effector systems need to be scalable. You need to have a layered defense. You need to have a command and control that hopefully acts somewhat autonomously and helps inform your operators what the right sensor and effector is to use for the threat at the right time based on the situation. And we certainly have the technology to do all that. We just need to go do it. and hopefully avoid a disaster. That's it.
Thank you, Evan, for describing the role of counter-drone system in the future. So in the future, it will be very important to keep up the pace with the fast changing nature of technology. Artificial intelligence is even more important to the future of military counter UAV systems. So here is the key to how to do the real-time processing of video feeds, create effective perception in a complex environment so that the commander can make the decisions very quickly. Right now, fully autonomous, artificial intelligence driven counter UAV solutions are mostly in the planning phase, but there are budding efforts to it. The counter UAV systems that uses artificial intelligence and deep learning identify and classify an approaching UAS or a swarm of drones and applies countermeasures to induce the device to land or return to its home base. So in the years to come, fully autonomous counter UAV systems capable of identifying and destroying malicious drones without human intervention could potentially police our skies. However, over the next decade, artificial intelligence is expected to play a growing role in the counter UAV systems in terms of helping these systems to better identify and track suspicious UAVs as well as more effectively predict and control the behavior of unwelcome drones. Over to you, Rahul.
Thank you all the speakers for discussing the potential of counter-UAS technology. After listening to all your perspectives, I can surely say that the organization in the counter-UAS industry will continue to tap more and more opportunities that will aid them in gaining a better understanding and consecutively providing more effective products for the future. With that thought, let me conclude today's session. And now I declare the forum open for any questions from the listeners. I request the listeners to kindly type in the questions on the Q&A box available on the bottom of your screen. And I will be happy to pass the questions to the esteemed speakers today. Oh, so we have a question for Evan. How do you see the government bodies investing for the procurement of counter-UAS solutions to protect their critical assets? Evan, can you answer that question?
I can, yes. So we're at a strange crossroads right now where, because counter-drone technologies are often new technologies, such as high-energy lasers and high-power microwaves and new types of missiles, such as the Coyote, it means that a lot of the laboratories, the U.S. Department of Defense laboratories, such as Air Force Research Lab and other organizations, are funding test and evaluation efforts, and they're funding exercises in which people bring these new technologies and they demonstrate them, demonstrate their maturity. And so different technologies right now are sort of being competing to establish a counter-drone baseline in these tests that are sponsored by the laboratories. But I think what we're going to see is a movement very, very quickly away from that kind of science and technology rapid prototyping effort, much like the rapid prototyping effort we're supporting with the Air Force on the laser. We're going to see that very quickly turn into efforts that take us to low-rate initial production, so to actually move these systems into production and hopefully get them really robust and mature, so that the lowest level operators can use them. And that'll mean that money will come not just out of the laboratory S&T budgets, but it'll start to come out of budgets that support urgent operational needs at the different combatant commands based on needs, forecasted in different regions. So the hope is that we're out of the S&T phase in these sensor and effector technologies, and we're moving very quickly through rapid prototyping right now, and ultimately getting into production, because that's really what we need to get the economies of scale to bring the price down on counter-drone weapon systems so that they can compete with the drone threat.
Right. Thank you, Evan, for the information. We have one.
Okay, sorry, here. Could I just add a perspective on that from the UK is in a slightly different position. In the UK, I mean, as Blighter, we've been manufacturing counter drone for quite some considerable time, and we're way beyond prototype stage by now. In the UK, there's an organisation called the Centre for the Protection of the National Infrastructure, which is a government body, which has been undergoing for the past year testing of counter-drone solutions, specifically in order to be able to certify and classify them for use in UK's critical national infrastructure applications, which include airports, nuclear power stations, prisons, etc., etc., etc. And those there's a list of those results is available through the CPNI for the UK. And we find that a lot of certainly UK-centric consultancy practices that are operating globally tend to follow CPNI guidance because it's there, and it covers a lot of different technologies. It's not just about counter-drone, it's about a lot of other risk management technologies for protection of critical infrastructure. And so that testing is well on the way in the UK. And the spend on counter-drone technologies in the commercial sector, anything, I'm including the power sector, for instance, the nuclear sector in that, as well as airports, as well as prisons. The spend is coming directly from the end users. So individual airports are spending their own money on counter-drone solutions. In the aviation spaces, in general, when you speak to ICAO, IATA, and ACI, there's still a huge argument going on between them about who should pay for counter-drone globally on airports. But unfortunately, our airports cannot wait for regulation and legislation to catch them up. Nobody wants to be another Gatwick. And so in many cases, these critical infrastructure facilities are already spending on counter-drone, and they're doing it either under the guidance of their own individual independent consultants in the UK, or in some cases, they're going directly to vendors and they're working with vendors.
Thank you, Evan and Geoff, for putting a very good insight on this question. So we have one more question coming for the panelists in general. For commercial aircraft in the US, which federal agency will likely be given the lead to help keep commercial aircraft safe from drone collisions, especially around the airport? Will we be allowed to keep, okay. So this is the question, it's open to the panelists.
Yeah.
So, yeah, go ahead.
Yeah, I was just going to chime in that, so as far as agency taking lead, FAA is going to take the lead on that one. What the actual solution looks like, it'll involve other agencies as well, but they'll take lead. What the solution actually looks like, though, ties in some of the other concepts that have been brought up as far as a UTM, and then registration of commercial drones. So there's a lot of moving parts. It's very early stage, but FAA will take the lead on it.
All right. Thanks, Matt, for the answer. There's one more question we would want to take quickly. Maybe Evan can answer this question. How to defend against swarm of drones, meaning like thousands of devices in the battlefield?
Yeah, so the first answer is a layered defense, where you have a number of different technologies, all that can deconflict and engage a number of targets at the same time. The next answer, to do it in a cost-effective manner, is probably very high power lasers that are being developed, like 100+ kilowatt lasers that we believe can shoot down a small drone in probably less than a second, right? So that means even if you have 100 drones, it might just only take you 100 seconds to shoot them down, and they might not go that fast. But obviously that technology is still being developed. And then high power microwave has the potential to be the holy grail, in that if you have a huge swarm, you can with a single pulse, kind of like an electromagnetic pulse, just drop them all out of the sky. So that is likely to be the best answer for dealing with drones on that scale.
All right, thank you, Evan, for the answer. We will have one last question from Geoff. What security measures can be put in place to prevent drones from accessing airspace? Geoff, can you answer that?
Yeah, well, all of the above really is the answer to that. And whatever we're doing in aerospace, it has to be a layered solution. We have to understand that there are very different requirements for different parts of the airspace. So the space around airports themselves and the approach and departure paths are very different from the in-flight path between airports or between countries. And there's a lot of difficulty in that space because at extremely long range, it's unbelievably difficult to detect a small flying piece of plastic at 30,000 feet in the air. So there's a lot of decisions to be made about that at the moment. There is a good argument to say that aircraft themselves should be carrying more detective systems in order to be able to detect small objects in their path. And if we consider what's going to happen in the near future in the urban mobility space, where we might have lots and lots of very small electrically driven vertical takeoff vehicles moving around inside of our cities, if you're worried about how much damage a small drone can do if it hits a jet airliner, imagine how much damage a drone could do if it hits a small flying taxi in the middle of a city. So we need to be looking at things like collision avoidance on small aircraft in the UAM space. But in the protection of airports themselves, the technologies that you need to use are entirely dependent on what you think or what you believe your operational requirements might be. At the moment, every single airport I've spoken to has got a different idea about what your operational requirement might be, whether they're trying to police an exclusion zone or whether they're trying to keep a flight line clear. There's lots of different ideas. The key thing is that you can't rely on any one single technology because you don't know exactly what the threat is. That's no different a lesson to anybody that works in the threat management industry, what we do every day of the week. You don't know what kind of person is going to break into your house next time or what they're going to do. And in exactly the same way, we do not know what the threats are going to be above our airspace. We need to continue looking at and deploying the correct combination of technologies and connecting them into systems that give you actionable output where operators can do the right thing at the right time. That's what we do. What those technologies are right now, we don't know all of the answers, but we've got a good idea. They're going to be detection technologies that can detect the moving dot in the sky and identify it, find out what it is, classify it, and then deploy the correct set of countermeasures. But don't forget, drones move incredibly quickly. And so there's going to be a lot of automation in future systems to be able to take out the man in the loop as much as possible from the decision-making process, because people are simply too slow for the rate at which drone-related incidents escalate.
All right, Geoff, thank you. Thank you all the panelists for the detailed responses that you have given for the questions. Unfortunately, we have now run out of time. And in the end, I would really like to thank all the speakers for joining us in this session. We have really learned a lot about the future of counter-UAS technology. With this, I conclude today's webinar. Thank you everyone again, and I wish you all a wonderful week ahead.
Thank you.
Thank you, gentlemen. Thank you, everyone.
Yeah, thanks very much. Cheers now.